Let ABC be an equilateral triangle. A new triangle is formed by joining the midpoints of all the sides of triangle ABC, and the same process is repeated infinitely many times. If P is the sum of all the perimeters and Q is the sum of all the areas of the triangles formed, here are the options. We want a relationship between the sum of the perimeters and sum of the areas. A word problem relating sequences in series. Let's see how to go about. So we are given an equilateral triangle ABC. Midpoints are joined. Midpoints are joined to form a new triangle. Let me call it as PQR. This process is continued. So these midpoints are joined to form another triangle that will also be an equilateral triangle. Let me call it as a DEF and so on. This procedure continues. Let's talk about the perimeter. Perimeter of triangle ABC. Perimeter of triangle ABC. Let's call the side of the original triangle as A. So perimeter is going to be 3A. Next we'll talk about perimeter of triangle PQR. Triangle PQR. We know that by using midpoint theorem, the line joining midpoints is equal to half the third side. So each side is going to be half of the original triangle. So each side of triangle PQR is A by 2. So perimeter is 3 times the side, so 3A by 2. So you can see that every smaller triangle inside will have the side as half of the previous triangle. So sum of the perimeters, which is denoted by capital P, is equal to perimeter of triangle ABC plus perimeter of triangle PQR plus perimeter of triangle DEF. That is going to be 3A by 4 and so on. So we'll have a triangle inside, another triangle inside. The process continues indefinitely. This is nothing but an infinite GP with the first term as 3A and the common ratio as half. Sum of infinite terms is equal to first term divided by 1 minus common ratio. So 3A divided by 1 minus half, which is equal to 3A by half, which is equal to 6A. Then they are talking about the sum of the areas of triangles. So area of triangle ABC. We know area of an equilateral triangle is equal to root 3 by 4 into square of the side. Then what is the area of triangle PQR? Triangle PQR will be root 3 by 4 into side is going to be A by 2 the whole square. So next, if you want area of triangle DEF is going to be root 3 by 4 into its side will be A by 4 the whole square. So they are talking about capital A as the sum of all the areas. So capital A is going to be root 3 by 4 A square plus root 3 by 4 A square into 1 by 4 plus root 3 by 4 A square into 1 by 16. The process continues, which is again an infinite GP with the first term as root 3 by 4 A square and the common ratio is 1 by 4. So first term divided by 1 minus common ratio. This gives us root 3 by 4 A square divided by 3 by 4. 4 gets cancelled. So we get this to be equal to A square divided by root 3. This is our capital A. And 6A is our perimeter, sum of all the perimeters. So I think the relations look like it is in terms of Q is the sum of the areas. I'm sorry, it is not A. Q is the sum of the areas. So they are talking about a relationship between P square and Q, or let's see, P square. Let's find out P square. P square is going to be 36A square, and you can see from here A square is equal to root 3Q. If you cross multiply this root 3 to this side, you get A square is equal to root 3Q and P square is equal to 36A square. So if you replace, you get P square is equal to 36 into A square, that is 36 into root 3 times Q. This is the relationship between P and Q. P square is equal to 36. P square is equal to 36 root 3Q. P square is equal to 36 root 3Q, which is going to be option B. So the answer to this question is option B, a simple question involving a word problem involving geometric progression.